This is the third part of the 17th lesson in heat transfer. In the 17th lesson, we have been developing a qualitative picture of convection heat transfer that will form the basis of how we interpret correlations for the convection heat transfer coefficients. By the end of this lesson, you should be able to explain the most critical variables that influence the value of the convection heat transfer coefficient. You should be able to understand why these variables are important based on the physics of boundary layer theory. The content of this lesson is a culmination of the previous lessons in lesson 16 and the first two lessons of lesson 17. On with the lesson.
So we're in a position now where we can kind of, this is like, we've kind of wrapped a bow on the qualitative picture that I've been trying to paint for you about what's going on behind convection heat transfer. And I'm trying to convince you that we are going to expect equations that allow us to calculate H. We're going to expect that those equations include the Reynolds number, include the Prandtl number, and include the thermal conductivity. And you should have a sense of why now, right? Like, why should the thermal conductivity matter there? It's because conduction still matters, right? Conduction at fluid solid interface, which is what the nature of the heat transfer is there. There's a no-slip condition. Fluid's not moving at the interface. It's stagnant there. So Fourier's law applies. Why do we have the Reynolds number in here? Right? Tells us about delta. Tells us about the thickness of the hydrodynamic boundary layer. Why does Prandtl number show up? Right? Gives us information about the relative thickness of the hydrodynamic and thermal boundary layers. And we know that for the convection story, what we really care about is the thermal, not the hydrodynamic one. We only care about the hydrodynamic one in so much as it influences what the thermal one is. So yeah, so that's what I'm trying to get you to see, is that it's not a mystery that you see these three things showing up in the equations for the convection heat transfer coefficients. That these three things say something about physically what's going on in the flow over the fluid-solid interface. It provides the information about the physics. It's how the physics is captured. Right? And you know something more about the physics now. So you can go back and read this slide, but the critical thing is to recognize kind of, yeah, what I want you to see is that why these things show up this way.